Already, I have given small homework also for you. So I make sure that I think you prepared ANOVA one-way classification and two-way classification pro formas. Yes, Bharati, did you prepare ANOVA one-way classification, two-way classification specimen? ANOVA one-way and ANOVA two-way classification already have given the specimen. Make sure to buy it and come to today's class. Okay. So we'll start the ANOVA. ANOVA is nothing but analysis of variance. ANOVA is nothing but analysis of variance. Okay. So it is a powerful statistical tool for test of significance. Okay, to test the significance, the importance of the problem, this ANOVA helps. Why? Because it is a very much powerful tool. So previously we used t-test for testing the significance of difference between two sample means. Okay. Previously we used t-test for use only when the sample size is 2. Okay. When the sample size is 2, then only we use t-test. But when we have 3 or more samples to consider at a time, we can use the F-test. F-test, that is for testing the hypothesis that all the samples are drawn from the same population or there is no significant difference between K sample means. So here, the variables, the sample values, what we drawn, they should belongs to only one family group only. Okay, all the variables, they should belongs to one area only. Then it is very much easy to solve the ANOVA one-way or two-way classification. So here, this can be done by using the technique ANOVA. Thus, the basic purpose of ANOVA is the homogeneity of several means. Homogeneity means all the samples they belong to only one group only. For example, here five fertilizers. See, for example, five fertilizers are applied to four plots, each of wheat and yield of wheat. On effect of these fertilizers on the yields is significantly different, or in other words, whether the samples have come from the same normal population. The answer to these problems is provided by the technique of analysis of variance. So here I have used one small example that five fertilizers they use for four plots. Okay, each of yield of wheat. Okay, when the fertilizers are used and the crop of wheat whether it is increased or not. Okay, so here more than five fertilizers are applying for four plots. Okay, such problems to get the answer, the technique no technique of analysis of variance will be applied. So here the term analysis of variance was introduced by Professor Ronald A. Fisher. Okay, you have to remember this name, Professor Ronald A. Fisher in 1920 to deal this problem in the analysis of agronomical data variance is inherent in nature. The total variation in any set of numerical data is due to a number of causes which may be classified as assignable causes and chance causes. So ANOVA was introduced by Professor Ian Ronald in 1920 to deal this problem in analysis of agronomical data variance is inherent in nature. So here the total variation in any set of numerical data is due to a number of causes which may be classified as assignable causes, chance causes. The assignable causes can be detected, can be determined, can be estimated, can be measured, whereas the chance cause cannot be determined, cannot be measured, but it is under the control of human and cannot be traced separately. The assignable causes can be detected. Okay, here see the difference between assignable cause and chance cause. See, assignable causes can be detected, can be determined, can be estimated, can be measured, whereas the chance cause cannot be determined, cannot be measured, but it is the under the control of human and cannot be traced separately. Okay, then uh, see these assumptions here. Assumptions are nothing but imagination. Imagination means here we have to assume what actually there in analysis of variance. Wait a minute. See here, the assumptions in analysis of variance are the same as discussed earlier while talking of F test. That is normality, homogeneity, independence of error. Okay, now it looks very normal. See, what are the assumptions of ANOVA is means when you look ANOVA problem, it looks very normal. And homogeneity means all the variables what we pick up, they belongs to one family only. Then they are independence in error, independence of error. They are not depending on each other. They are independent here. Then here the technique of ANOVA. For the sake of clarity of technique of ANOVA, it has been discussed separately. That is steps in calculating one way and two way. So here only two techniques are there. That is ANOVA one way classification and ANOVA two way classification. So we are going to see one way classification. So this is the formula. Calculate the ratio F as follows. F is equals to variance between the samples divided by variance within the samples. Okay, so here already in the previous class we have discussed regarding this table, that is ANOVA table one-way classification model, that is sources of variation, sum of squares, degrees of freedom, mean squares, variance ratio of F between samples, within samples, then total, between samples, within samples, then total. So you observe carefully, just by hand like this, between samples, within samples, between samples, within samples, then you will get the total. That is sum of squares. That is SSC, SSE, SST, SSC, SSE, SST. Then degrees of freedom. V1 is equals to C minus 1. Then V2 is equals to N minus C. Then K is equals to N minus 1. Okay, what is this SSC and what is this SSC and what is the SST? You will get complete clarity after solving a problem. So till now, please, if you have any doubt, at the end of the class, I will give for you for 5 minutes. Then we go for clarification of the doubts. Till that time, you have to listen the class. Okay, then you will get a complete idea about this ANOVA one-way classification table and more than called as a model. Then here, to know the V1 and V2, see separate, there is a table values will be there. All these table values are before only it will be written by the statistician in SP Gupta book in the back side, just like algorithm tables. Okay, algorithm tables, it will be written that is 5% ANOVA table value and 1% ANOVA table value. The table values, okay, what are there in the back of the SP Gupta statistical methods book, the same table value used for ANOVA two-way classification and the ANOVA one-way classification. There is no separate table values for ANOVA one-way and the ANOVA two-way. So we are going to use the only one table value. Okay, but here one way, one way, 1% LOS is there and 5% LOS is there. So based on the problem, we are going to use 1% or 5%. Okay. So here mean squares, that is MSC is equals to SSC divided by C minus 1. See here, MSC is equals to SSC divided by C minus 1. Then MSE is equals to SSE divided by N minus C. Then SST. Okay, these are the total. See, this is the total. This is called SST. The next one, this MSC value is divided by MSE. We call it as F variance ratio of F. This is called as variance between samples divided by variance within sample. Variance between samples divided by variance within sample. Okay. So I think you got complete clarity. So again, we will go, see some additional information regarding this table. So whereas see SST is equals to total sum of squares of variations. SSC is equals to sum of squares between samples, that is columns. SSE is equals to sum of squares within samples, that is rows. Then MSE is equals to mean sum of squares between samples. MSE is equals to mean sum of squares within samples. Note number one, the same procedure for analysis of variance is applicable for both the equal and unequal sample values. See, note number one is most of the important here. Why? Because, say, for example, the problem will be like this. See, I'm drawing a small table. So here we will see in this table some different values, numbers will be there. See, what is the table size, matrix size of this table? Anybody? Yes, Bharati, Mahinder, and someone Vivo V21343 is there. By observing this table, what is understood for you? Note number one is important here. See, note number one is important here. The same procedure for analysis of variance is applicable for both the equal and unequal sample sizes. For example, the question will be like this here. See, this is a table 1, 2, then here 4, then 5. Okay, they will give the numbers according to their wish. Don't worry, I'm not continuing. The between number, that is 3, I missed here. 3, 9, 0, 1, 5. Again 3, 1, 1. Okay, so you observe carefully here. See in the first row, see first column, 1, 3, 0, 1 is there. Or you write here 10. 1, 3, 10, 1. So all values are there. But in second column, 2, 9, 5. See here there is no value. You see there is no value here. And the column 3, 4, 3, and again values, numbers are not there. Then 5, 1, 1, and no values are there. Okay, sometimes the problem will be like that. Okay, you observe carefully this one, the problem. Okay, so here in each and every table, see, in column 1, all the numbers are there. In column 2, only 3 numbers are there. In column 3, 2 numbers are there. In column 4, only 3 numbers are there. Okay, sometimes what happened, the table will be completely, it will be filled with all the values. So the table which I written, see, you observe the screen, the table is called as unequal values table. So equal value table means it will be having all the numbers in all the boxes. So even though this type of problem will be appeared in the question paper, or sometimes in the question paper, all values will be there. Then immediately what we have to do? We have to follow the same procedure which we are going to apply for equal values. The same procedure will be applied for unequal sample sizes only. Okay, this is one clarity. The next one, note number 2. Assume 5% level of significance if LOS is not given in the question. See, this is the question. See, this is the question. Then after giving this question, after this question is appeared in the question paper, apply ANOVA. Okay, example will be given like this. Apply ANOVA at 5% LOS. LOS will be mentioned. If LOS is not mentioned, that is 5%, then also we have to follow 5% only. If it is given 5%, we have to follow 5% only. Sometimes what happened, instead of 5%, the examiner will provide 1% only. Okay, 1% only. So anybody any doubt in this table?
No, sir.
Okay, I think you understood this one. So I'm moving to the next step here. Right. See here, now we'll start the problem. If you want to take a screenshot, you can take the screenshot. So you observe carefully problem, that is to assess the significance of possible variation in performance in a certain test between the grammar schools of a city. A common test was given to a number of students taken at random from the senior fifth class of each of the four schools concerned. The results are given below. Make an analysis of variance of data. Okay, so here in a city, grammar schools are there. Okay, so from the senior fifth class, they have taken a common test was given to a number of students taken at random from senior fifth class of each of four schools concerned. So here schools A, B, C, D. So schools are here A, B, C, D is there 8, 10, 12, 8, 7. Then 12, 11. Okay. So 12, 11, 9, 14, 4. C, school 18, 12, 16, 6, 8. Then D, 13, 9, 12, 16, 15. So this is the given question. So you observe carefully. In all columns, everything is there. So this problem is called as equal model problem. Unequal problem means in any column, a number will be missed. So any equal or unequal, we have to follow the same procedure. In procedure, there is no doubt. Okay, in procedure, there is no doubt. Okay, so you observe carefully the table. Right. It table looks very simple. Table looks very simple. So this is the solution here. You observe carefully. So in this problem, see nothing is mentioned regarding LOS. 5% and 1%. LOS is not mentioned. So what we have to do? We have to apply and we have to assume that we have to apply 5% LOS only. Okay. So here the calculation of ANOVA table. See, instead of schools, I am writing a calculation of ANOVA table. A, B, C, D, sample 1, sample 2, sample 3, sample 4. Any doubt, anybody? In this is, see, you observe carefully. The same question I am writing here instead of school A, B, C, D, I am writing here sample 1, sample 2, sample 3, sample 4. Okay. The values, what is there in question, the say all values will be copied till here. Till here, the same values will be copied from the question paper. Then simply what we have to do, first step is here, just do the total of above these values. These values, total. That is for 8 plus, 10 plus, 12 plus, 8 plus 7. That is 45. Then 12 plus, 11 plus, 9 plus, 14 plus, 4. plus the total is here 50. Then sample 3, 18, 12, 16, 6, 8. The next over here, 13, 9, 12, 16, 15. All the totals are 45, 50, 60, 65. These are the total values. After doing the total, just find the average of above number. That is 45 divided by 5. 5 means number of values are here. See, how many rows are there? Rows are there? 5 rows are there. Row 1, 8. Row 2, 10. Row 3, 12. Row 4, 8. Row 5, 7. So 45 divided by 5, you will get the answer is 9. Then 50 divided by 5, you will get the answer is 10. 60 divided by 5, you will get the answer is 12. Then 65 divided by 5, you will get the answer is 13. So till here, anybody any doubt?
No, sir, clear.
Okay, clear. So then after doing all these steps, next we need to find out the grand mean. Grand mean of averages recorded as X. See, the principle is here. X double bar, not single bar. X double bar is equals to X bar 1 plus X bar 2 plus X bar 3 plus X bar 4 by C. That is number of samples, number of columns we can say. That is here, see, 9. X bar values, X bar values. X double bar is equals to 9 plus 10 plus 12 plus 13 divided by 4. The total of 9 plus 10 plus 12 plus 13 is equals to 44 divided by 4 is equals to 11. Then grand mean of all samples. Okay. The first step is we completed. Then second step is here. Grand mean of all samples. X double bar is equals to sigma x1 plus sigma x2 plus sigma x3 plus sigma x4 divided by n. That is 45 plus 50 plus 60 plus 65 divided by 20. Okay, 220 divided by 20 is equals to 11. Okay, so you observe carefully, N stands for total number of individual samples. Total number of individual samples means in column 1, as per the question, how many samples are there? See, 1, 2, 3, 4, 5. 5 samples are there. Again in column 2 also 5. That is 10. Again column 3. Okay. Again column 4. How many columns are there? Total 4 columns are there. In each column, 5 sample values are there. That is 5 into 4, that is 20. The total 45 plus 50 plus 60 plus 65. Okay. 65. That the total is called here 220. Okay. Divided by 20. You will get 11. See, you will get the X double bar. That is the grand mean of averages and grand mean of all samples. 11 and 11 in 2 cases. This is the main criteria. If you get the same values, sometimes you will get 10 in the first case, in the step number 1. And in the second also, you need to get 10 only. Otherwise, you done a small mistake. Okay. So now, see, now the SSC value we are going to find out. See, this SSC value step will begins here between samples. First step, variance between samples. So you observe carefully. To obtain variation between samples, calculate the squares of deviation of the various samples from the grand average. The mean of sample 1 is 9, but the grand mean is 11. So we have to take the difference between 9 and 11 and square it. Okay. See, you observe carefully. The mean of sample is 9 here. Yes or no? The average is 9, but the grand average is 11. 9 minus 11, how much? 2. Okay. 2 square, 4. You will get the answer is 4. See, I'm written in the sample 1, 4, 4, 4, 4, 4, 5 times I have written. The same manner, similarly, for sample 2 also, the mean is 10, but the grand average is 11. That is here, 10 minus 11 is 1. 1 square is 1, 1, 1, 1, 1. Again, the next one is here. 12 is the average value, but the grand average is here 11. 12 minus 11, that is 1. Again, you will get 1, 1, 1, 1. Then 13 minus 11, that is 2. 2 square, 4, 4, 4. Okay. Then the final answer is 20 plus 5 plus 5 plus 20. Sum of squares between sample is equals to 20 plus 5 plus 5 plus 20 is equals to 50. Okay. After getting the 50 value, we got these values called as SSC, sum of squares between columns or between samples. See, 20, 5, 5, 20 is a 50. This value is called as S, S, C. S, S, C is the first one. Then after the SSC, variance, degrees of freedom. Degrees of freedom, that is V1 is equals to C minus 1. C minus 1 is equals to 4 minus 1 is equals to 3. Okay, 4 minus 1 means here C stands for columns. How many columns are there? Sample 1, sample 2, sample 3, sample 4. 4 columns are there. So here 4 minus 1 is equals to 3. Okay, V1 is equals to 3. Then mean sum of squares between samples is 50. Same. Mean sum of squares, that is SSC divided by C minus 1. See here, SSC value is 50. Then C minus 1 is 4 minus 1, that is 3. 50 divided by 3 is equals to 16.7. Because there are 4 samples and the degrees of freedom are 4 minus 1 is equals to 3. Okay. So the first part, variance between samples, we completed. Till here, anybody, any doubt? You can ask the doubt.
Sir,
Hmm.
can you tell me once again how it will 4 and 1, 1, 4 comes? Sample 1, sample 2.
Okay, okay. Once I will repeat, wait. So listen carefully once again. So these are the steps very much important for us. Okay. Once again, you look here carefully. See what we done? We simply, instead of writing A, B, C, D, have written sample 1, sample 2, sample 3, sample 4. Clear? This clear. X1, X2, X3, X4. 8, 10, 12, 8, 7. So these are the values we taken from the question paper only. So the total of first sample is 45. Total of second sample is 50. Total of sample 3 is 60. Total of sample 4 is 65. Then X bar is 9, 10, 12, then 13. These are the averages. Okay. Any doubt regarding total and average?
No, sir.
Okay. So after completion of finding out the total and average, the next step is grand mean of averages, grand mean of all samples. So grand mean of averages. So the principle is x double bar is equals to x bar 1 plus x bar 2 plus x bar 3 plus x bar 4. Okay, wait a minute. Okay. So grand mean of all samples. Grand mean of averages, x double bar is equals to x bar 1 plus x bar 2 plus x bar 3 plus x bar 4. Then here 9 plus 10 plus 12 plus 13. Okay. How many columns are there? 4 columns are there. So 44 divided by 4, that is 11. It is understood? It is clearer?
Clear, sir.
ఓకేనా?
ఓకే సార్, ఇక్కడ వరకు క్లియర్ సార్.
ఓకే. సో నెక్స్ట్ ఫస్ట్ స్టెప్ అయిపోయిన తర్వాత నెక్స్ట్ సెకండ్ స్టెప్ చూడండి. గ్రాండ్ మీన్ ఆఫ్ ఆల్ శాంపిల్ అగైన్ ఎక్స్ డబల్ బార్, దట్ ఈస్ సిగ్మా x1. సి ఐ am taking sigma. Sigma indicates the total. Sigma sign indicates total. Sigma x1. See, this is the first
ఎస్ సార్.
total. Sigma x1, sigma x2, sigma x3, sigma x4. Okay, that is 45, 50, 60, 65. The total is 220 divided by 20. Okay, now divided 20 means in column 1, column 2, column 3, column 4. Five samples are there individually. The total is 20. 220 divided by 20, that is 11. Okay. Then again you will get 11. See here, you got 11 and you got 11. So if you are doing any practice problem, you should get the same values in the first case and in the second case also. So after getting these values, you start doing sum of squares between columns. So see, you observe carefully. So now we are going to start between sample SSC value and V1 is equal to C minus 1. Then MSC is equal to SSC by C minus 1. This SSC value we need to find out. SSC value we need to find out. So to get this value, one procedure we are going to follow. That procedure, just look now. To obtain variation between samples, okay, calculate the squares of deviation of various samples from the grand average. The mean of sample 1 is 9. Mean of sample 1 is 9. Mean means average. Average is 9, but the grand mean is 11. Okay, in the first step we got 11 and the second step we got 11. So 9 minus 11 is 2 and simply square it. 2 square, how much? 2 square, how much? So this is the procedure only. 2 square 4, 2 square 4, 2 square 4, 2 square 4, 2 square 4. So we have to write 5 times here. Why? Because in sample 1, 5 samples are there. That is the reason we have to write 5 times here. The next, the second, similarly, sample 2. Mean is 10, grand mean is 11. 10 minus 11 is 1. 1 square 1, 1 square 1, 1 square 1, 1 square 1. So 5 times again you have to return. The next one is grand mean. See, mean average. Mean is 12, grand mean is 11. 12 minus 11 is 1, 1, 1, 1. 1 square, 1 square, 1 square, 1. Okay. The next one is 13. 13 minus 11. 13 minus 11 means the mean is 13 and the grand average or grand mean is 11. 13 minus 11 is 2. 2 square 4, 2 square 4, 2 square 4, 2 square 4, 2 square 4. Then simply do these totals. Total is 20. Total is 5. Total is 5. Again, total is 20. Any doubt, anybody?
Sir, ఒకసారి
Yes.
మళ్ళీ
సార్ శాంపుల్ 2లో 10 మైనస్ 11 అంటే -1 వస్తుంది కదా సార్?
మైనస్ తీసుకోకండి, మైనస్ తీసుకోకండి అసలు. ఇక్కడ ఈ ప్రాబ్లంలో మైనస్ తీసుకోకండి. ఓకే, పాజిటివ్ వాల్యూ కన్సిడర్ చేయండి. ఓకే, వన్స్ అగైన్ ఒకసారి వినండి, కొంతమంది డౌట్ ఉందట. సో ఇక్కడ లిజన్ కేర్ఫుల్లీ. Listen carefully. Why? Because this problem is compulsory for your examination point of view. The scoring marks, this problem comes under scoring. So you observe carefully. See, total here, average is 9 for sample 1, average 10 for sample 2, average 12 for sample 3, average 13 for sample 4. To get all these values, sample 1, sample 2, sample 3, sample 4, what I am doing here, see 9 minus, this is we called as mean. Okay, this is called as mean value. Where the mean value is there? Well, first mean value is 9. 9 minus 11, how much? 9 minus 11. 2. Okay, my 9 minus 11 is 2. Simply square it. 2 square, 4, 4, 4, 4, 4. 5 times you have to write. Then second one, 10. 10 minus 11. 10 minus 11 is 1. 1 square 1, 1 square 1, 1 square 1, 1 square 1. You have to write 5 times. Then 12 minus 11. Okay, 12 minus 11 is 1. 1 square 1, 1 square 1, 1 square 1, 1 square 1, 1 square 1. Then 13 minus 11. Okay, 13 minus 11, that is 2. 2 square 4, 2 square 4, 2 square 4, 2 square 4. Okay, so I think you understood this one.
Yes.
Okay, then next, simply add all these values. The first sample is 20, second is 5, third is 5, and fourth is 20. So SSC is equals to 20 plus 5 plus 5 plus 20 is equals to 50. SSC is equals to 50. Sum of squares between columns is equals to 50. SSC వాల్యూ వి గాట్. అంటే ఈ వాల్యూస్ అన్ని ఫైండ్ అవుట్ చేసిన తర్వాత ఆ టేబుల్ ఉంది కదా, ఆ టేబుల్లో ఇన్సర్ట్ చేయాలి మనము. ఓకే సార్, ఐ థింక్ యూ అండర్స్టూడ్. ఓకే, యూ హెవ్ టు ఇన్సర్ట్ ఇన్ ద ప్లేస్ ఆఫ్ SSC the 50 number 50 you have to insert. Then degree of freedom V1 is equals to C minus 1. C stands for columns. How many columns are there? 4 columns are there. 4 minus 1 is equals to 3. Okay, 4 minus 1, that is 3. Okay, then next one, mean sum of squares between samples. That is MSC divided by C minus 1. MSC is equals to SSC divided by C minus 1. In the place of SSC, what we got? We got 50, 50, 50. Then C minus 1, that is 4 minus 1. 50 divided by 3 is equals to 16.7. Okay, just look into that again carefully. Sum of squares between samples, degrees of freedom, mean sum of squares. Once you look for, okay, once look it carefully. Okay, I think you understood, huh? Any doubt?
No doubts, sir. Clear.
Okay, okay. So I'm moving, so we got SSC value, then C minus 1 value, MSC value. Okay, then next we need to find out the variance within sample. That is SSE value and V2 value. The next MSE value. Okay, so here, see, for the first table, one procedure will follow. For the second procedure, we need to follow the another step. So for each and every method, there will be different steps will be there. So you observe carefully. So variance within the samples. Here we find the sum of squares is the deviation of various items in a sample from the mean values of respective samples. Thus, for the first sample, then the mean is 9, and so we will take the deviation from 10. So on, the square deviations are given in the following table. Okay, you observe carefully. See, these x1 values are you have taken from the question. You observe carefully. Okay, in the same manner, x3 value also. X3 value also. See x3 value. Simply we copied from the question paper only all these values. Okay. So to know the sample value, to get the SSE values, the procedure we are going to follow. See here, x1 minus x bar 1 whole square. x1 value is 8. X bar 1 how much, Nana? X bar 1 how much? X bar, I am not using x double bar. X bar 1. How much, anybody?
11, sir.
11? No, 11 కాదు. ఎక్స్ బార్ అంటున్నా నేను, ఎక్స్ డబల్ బార్ అంటలేను. స్టెప్ 1 లో ఎక్స్ డబల్ బార్ ఫైండ్ అవుట్ చేసినాం, స్టెప్ 2 లో ఎక్స్ డబల్ బార్ ఫైండ్ అవుట్ చేసినాం. ఎక్స్ బార్ అంటే యావరేజ్ 45 డివైడెడ్ బై 5. హౌ మచ్ వి గాట్?
9, sir. 9.
Yes, that is average. Average, the another name of average is x
Yes.
bar. Okay. 8 minus 9, how much?
1.
1 square, 1. Any doubt? Again, x1 minus x bar 1 whole square. 10 minus 9, that is 1. 1 square, 1 only. The next one, 12 minus 9, how much?
3, sir.
3 square, 9.
9.
Right. Then 8 minus 9, 1. 1 square, 1 only. Then 7. 7 minus 9,
2.
right. That 2 square is 4. Okay, it is clear, all of you?
Yes, sir.
The first sample 1 step is clear. The next one, sample 2. The same procedure. Say x2 minus x bar 2 whole square. x2 minus x bar 2 whole square. That is 12 minus 10. 12 minus 10, how much? 2. 2 square, 4. 11 minus 10, 1. 1 square, 1. 9 minus 10, 9 minus 10, 1. 1 square, 1 only. Then 14 minus 10, 4. Okay. 4 square, 16. The next one, 6 minus 10. 6 minus, sorry, 6 minus 10, how much, Nana?
4.
10, see here, 4 minus 10, sorry. 4 minus 10 is 6. 6 square, 36. Okay, after getting all these values, just do the total. You will get the answer is 16 here. Again, do this total. You will get the answer is 58. The same procedure apply for sample 3, sample 4. Okay, 18 minus, what is the average here? X3, X bar 3 average how much? X bar 3 average ఎంత ఉంది?
12.
18 minus 12?
6.
6. 6 square, 36. Okay, you got 36
30.
here. Okay, you got 36. The next one, 12 minus 12?
0.
0 square, 0. 16 minus 12?
4.
16 minus 4 square? 16.
16.
6 minus 12? 6 minus 12, how much?
6.
6, 6 are 36. 8 minus 12? 4.
4.
4, 4 are 16. Okay. So we got sample 3 values also. The total is 104. Okay. The next x bar 4. The average, the average. How much? X bar 4, how much, Amma? X bar 4, how much? X bar 4, how much? Yes. X bar 4 is 12, 13. X
13.
13. Okay. 13 minus 13. See here, 13
0.
is there. 13 is there here. 13 minus 13 is 0. We got answer. 0 square, 0 only. 9 minus 13,
4.
4 square, 16.
16.
12 minus 13,
1. 1.
1 square.
1.
16 minus 13,
3.
3
3.
square. 3 square,
9.
9. 15 minus 13,
2.
2 square.
4.
Okay, the final is here, total is 30. Okay, anybody need doubt? So in the second step here, see x1 value, x2 value, x3 value, x4 value. Just copy from the question. Simply additionally, you have to do this step. X1 minus x bar 1. Okay, x2 minus x bar 2. X3 minus x bar 3. X4 minus x bar 4. Okay, so we got all the total values. The totals are here. Sigma x1 minus x bar 1 whole square is 16. Sigma x2 minus x bar 2 whole square is 58. Sigma x3 minus x bar 3 whole square is 104. Sigma x4 minus x bar 4 whole square is equal to 30. Sum of squares within the samples is 16 plus 58 plus 104 plus 30 is equals to 208. That value is called as SSE value. Okay. Sum of squares within sample is equals to 16 plus 58 plus 104 plus 30 is equals to 208. That is SSE value. Any doubt, anybody?
No, sir.
Okay. So after getting SSC value, degrees of freedom as per the specimen of the ANOVA one-way classification, that is V2 is equals to N minus C. N stands for total number of samples. There are 20 total number of samples are there. That is a 20. Then minus C. C stands for columns. How many columns are there? 4 columns are there. 20 minus 4 is equals to 16. 20 minus 4 is equals to 16 here. Then mean sum of squares within the samples. That is 208 divided by 20 minus 4. 208 divided by 16. So that is 13. MAC is equals to 13. So see, yeah, between samples completed, within samples completed. Okay, after completing all this value, simply insert the values in the table. But before inserting the values, so if you have any doubt whether the problem which what we done, it is clear or not. So we have to check again here. So it is advisable to check up that the calculations by finding out total variation. Total variation is calculated by taking the squares of the deviation of each item from the grand average. So this is the one more step. If you want to do in examination point of view, you can do, otherwise no need. So these table, so whether we done our calculation is right or not. Okay. So with the help of this table, we can check the values. So the same procedure here, x1, x2, see x1, x2, x3, then x4. That is 8, 10, 12, 8, then 7. These are the from question. So here what in the previous within sample, x1 minus x bar is there, but we have to take x double bar here. x1 minus x double bar 1. X double bar, sorry, x double bar. So x1 minus x double bar. 8 minus 11. 8 minus 11, how much?
3.
3 square, 9. Minute out. Then
No,
10 minus 11, 1. 1 square, 1. 12 minus 11, 1. 1 square, 1. 8 minus 11, 3.
3.
3. 3 square. 9, that is. 7 minus 11, that is 4. 4 square, 16. The total is here 16. సి ఇంతకుముందు చేసిన బిఫోర్ ప్రాబ్లంలో యావరేజ్ తీసుకున్నాం ఎక్స్ బార్ తీసుకున్నాం బట్ ఇక్కడ ఎక్స్ డబల్ బార్ తీసుకుంటాం Okay. You observe carefully. X bar, X double bar. The next, these are the values we taken from the question. Okay. Then x2 minus x double bar, 2 whole square. 12 minus 11, 1. 1 square, 1 only. 11 minus 11, 0. 9 minus 11, 2, 2 square, 4. 14 minus 14 minus 11, 3. 3 square, 9. 4 minus 11, 7. 7 square, 49. Okay.
40.
The total is here 63. Again, x3 values. All these values we have taken from the question itself. X3 minus x double bar 3 whole square. 18 minus 11, that is 7. 7 square, 11. Okay. Then 12 minus 11, that is 1. 1 square, 1. 16 minus 11, how much? 5. 5 square, 25. Then next one is 6 minus 11, 5. 5 square, 25. 8 minus 11, 3. 3 square, 9. The total is 109. Okay. Then next one is here. The next one, the sample 4. See, these we have taken from the question itself, from the question paper. The next one, 13, see, x bar, sorry, x4 minus x double bar whole square or x double bar 4 whole square. See, 13 minus 11, how much? 2. 2
2.
square, 4. Then 9 minus 11, 2. 2 square, 4. 12 minus 11, 1. 1 square, 1. 16 minus 11, that is 5. 5 square, 25. 15 minus 11, 4. 4 square, 16. Okay, this is the total. So after doing all these totals, how much the value we are going to get, we will check here. So the total sum of square is equals to 36 plus 63 plus 109 plus 50. The total is 258. Okay. So this table is the additional table. If you want to do in examination point of view to check whether your calculation is correct or not, you can do it. Otherwise, not required. No need to do this one. But it's my primary duty. So we're done the here. So you observe carefully. The first table, how much we got? We got 50. 5050. You observe carefully. 5050, the totals. Okay. Then in the second table, we got 208. 208, see, 50 is SSC value. So you have to remember the specimen. SSC in the place of SSC, 5050 is there. In the place of SSE, 208 is there. In the place of SSE, 208. The total is called as SST. Total sum of squares is SST. That is 258. So we got here 258 when we done the last table. 258 we got. అంటే మనం చేసిన calculation correct అన్నట్టు. So here degrees of freedom is n minus 1. Okay, degrees of freedom n minus 1, that is 20 minus 1 is 19. So if you calculate, see, degrees of freedom also, if you do calculation, so you observe carefully, the first degrees of freedom is how much? You got 3. 3 plus 16. 3 plus 16 how much? 19. Again, degrees of freedom also, our 19 we got, our calculation is correct. So when we add the sum of squares between samples and sum of squares within samples, we got the same total, that is 50 plus 208, that is 258. Hence, our calculations are correct. So all the above results are tabulated as follows. See, this is the final table. Okay. ఆల్రెడీ నేను చెప్పాను ప్రీవియస్ క్లాస్ లో మీరు బై హ్యాట్ చేసుకొని రండి. ఓకే, ఆ బైహాడ్ చేసిన వాల్యూస్ మనం ఇక్కడ పెట్టాలి. ఇప్పుడు చూడండి, సోర్స్ ఆఫ్ వేరియేషన్ బిట్వీన్ శాంపిల్స్, విత్ ఇన్ శాంపిల్స్, సమ్ ఆఫ్ స్క్వేర్స్, డిగ్రీస్ ఆఫ్ ఫ్రీడమ్, మీన్ సమ్ ఆఫ్ squares. Then last one is variance ratio of F. So I have written separately here variance ratio of F, that is the F value. Or you can write this here also. You can create one more column. That is up to you. So it is not required. So it is only advisable. So here sum of square SSC value is 50. First table is 50 వచ్చింది. Second table is 208 వచ్చింది. Okay. Exam లో థర్డ్ టేబుల్ చేయండి చేయకపోండి మీ ఇష్టం. You can do or you cannot do. That is up to you. The third table. See 50 plus 208. That the total is 258. So while we are doing the third table, we got 258 the final answer. Okay, if you do this total, so you are going to get the same one, that is 258. Then V1 is equals to 3 and V2 is equals to 16. Then K is equals to 19. Okay, it is clear? Then 50 divided by 3, 50 divided by 3, that is 16.7. Then 208 divided by 16, that is 13.0. 13.0. So F is equals to variance between samples divided by variance within samples is equals to 16.7 divided by 13.0. That is 1.285. These values called as, okay, this value is called as calculated value. See, this value is called as 1.285 value is called as calculated value. This calculation is done by us only. So we done calculation. Okay. So till here we completed the problem. After getting the calculated value, simply you have to write a small conclusion. Conclusion is most important here. Conclusion is most important. That is comparison of calculated value with the table value or critical value. The table value is there or critical value. So I request you to take the table values from SP Gupta book, statistical method book లో లాస్ట్ లో ఎండింగ్ పేజెస్ లో లాగరిథం టేబుల్ స్టైల్లో కొన్ని టేబుల్ వాల్యూస్ ఉంటాయి. అనోవా 5%, అనోవా 1% మీరు అక్కడ తీసుకోవచ్చు. లేదా అదర్వైజ్ యూ కెన్ గెట్ ఫ్రమ్ రీసెర్చ్ మెథడాలజీ బుక్, టెక్స్ట్ బుక్, the ending pages, the last pages. There, the table values will be there. That table values are called as critical value also. So the table value of for V1 is equals to 3. Okay, V1 is equals to 3 and V2 is equals to 60 at 5% LOS is equals to 3.24. 3.24. So you observe carefully here, like this, the table will be there. Table will be there like this. So these are the V1 values and V2 values will be there. 1, 2, 3, 4, 5, 6. Then 1, 2, 3, 4, 5, 6. Like this, the ANOVA table values there. So here, in the top side here, these are the V1 values. This side, and these are the V2 values, the downside. So you observe carefully. V1 is equals to 3. V1 is equals to 3. This is the V1, 3. And V2 is equals to 16. The common point is here. The value will be there here. That is 3.24. See here, the 3.24 will be written. These values called as table value or critical value. So the calculated value of F is less than the table value. Hence, the difference in the mean values of samples is not significant. We accept H naught. Otherwise, the calculated value 1.285 is less than 3.24 from the table value. Hence, there is no significant difference between the samples. We accept H naught. Ila raste, you are going to score the good marks. Okay? Yes, still here, anybody in a doubt?
Okay, sir.
డౌట్ ఉంటే అడగండి అమ్మా, మరి నేను మళ్ళీ రిపీట్ చేయను. ఓకే, సో ఐ విల్ గివ్ సమ్ హోంవర్క్ ప్రాబ్లమ్స్ ఫర్ యూ. సో యూ షుడ్ జస్ట్ డూ ప్రాక్టీస్ అండ్ పోస్ట్ ఇన్ ద గ్రూప్. గ్రూప్ ఉంది కదా, ఆ గ్రూప్లో పోస్ట్ చేయండి ఆన్సర్ చేసి. నేను కరెక్టా కాదో
Okay.
నేను చెప్తాను మీకు. ఆర్ ఇన్ ద నెక్స్ట్ క్లాస్ come with answers, solutions.
Okay.
So wait a minute. ఓకే, సో ఐ థింక్ యూ అండర్స్టూడ్ దిస్ ప్రాబ్లమ్. నేను డౌట్స్ ఉంటే అడగండి అమ్మా, ఇంకా డౌట్స్ ఉన్నాయా ఎవరికైనా?
No,
సో మీన్ వైల్ ప్లీజ్ నోట్ డౌన్ ది హోంవర్క్ ప్రాబ్లమ్స్. సో డూ ప్రాక్టీస్ కంపల్సరీ. మీరు ప్రాక్టీస్ చేయకపోతే మీకు మార్క్స్ రావు, గుర్తుపెట్టుకోండి అమ్మా. చాలా ఇంపార్టెంట్ ప్రాబ్లం, స్కోరింగ్ ప్రాబ్లం.
okay.
ఓకే,
Okay.
ఇట్స్ ఇంపార్టెంట్ ప్రాబ్లం అండ్ scoring problem. So this is one shortcut method is there. Now it is not required, but you can do that method only.
Sir, excuse me.
Yes, చెప్పండి.
ఈ పీడిఎఫ్ మీరు మాకు ఫార్వర్డ్ చేయగలరా?
గ్రూప్ లో పెట్టాలా?
ఎస్ అంటే
క్లాస్ ఎండ్ అయినాక మొత్తం పెట్టేస్తా. మరి మీకు ఒక ప్రాబ్లం ఇస్తా, ఒక్క నిమిషం ఆగండి. ఈ ప్రాబ్లమ్ని కొంచెం ఫోటో తీసుకొని ఆ ప్రాబ్లం చేయండి ఇంటి దగ్గర.
ఓకే.
రైట్. ఈ ఫోటో తీసుకుంటామా? డైరెక్ట్ ఆన్సర్ చూపిస్తున్నాం మీకు. ఈ ఫోటో తీసుకోండి. x1, x2, x3, 8, 10, 7, 14, 11 వరకు చేసుకోండి. ఈ టోటల్ అవి చేయకండి. x1, the next two 7, 5, 10, 9, 9. Okay, x3 12, 9, 13, 12, 14. అయిందా? నోట్ చేసుకున్నారా? ఒకటే ప్రాబ్లం చేయండి. ఇంకేమైనా ఉంటే నేను గ్రూప్లో మీకు పంపిస్తా.
Okay.
రైట్. Okay, so now I am moving to ANOVA two-way classification. So here, see, observe carefully. ANOVA in two-way classification model. ANOVA two-way classification model. See, one way we completed. Now two-way we will see ANOVA two-way classification. In one-factor analysis of variance, explained above, the treatments constitute different level of single factor, which is controlled in the experiment. Many situations in which the response variable of interest may be affected by more than one factor. For example, sale of max factor cosmetics in addition being affected by point of sale display might also be affected by the price charged. The size and on the location of the store or the number of competitive products sold by the store. So here similarly, petrol mileage may be affected by the type of car driven, the way it is driven, road conditions, and the other factors in addition to the brand of petrol used. So here in two-way classification, two factors will be involved here. So the point of sale might be also be affected by the price charged. So where we are selling a product and the price of the product, the size and the location also. For example, in villages, you take example of thumbs up bottles or Sprite bottles. So if you go to D-Mart, the price of a thumbs up bottle is only 80 rupees. That is 2.35 liters bottle. So the same bottle will be sold in villages for 100 or in some places 120 also. Why? Because the demand for that product is there and the non-availability of product also, the scarcity of problem also there. Okay, based on the scarcity, the price will be dependable. So here two factors will be there. Then similarly, petrol mileage may be affected by the type of car driven. Okay, the way it is driven, road conditions, and other factors in addition to the brand of petrol used here. So the sometimes the petrol. See how many types of petroleum companies are there? Anybody? Any companies in petroleum companies?
Companies.
Okay, petrol. And how many types of petrols are there?
Bharat, Indian, HP,
Hmm.
Gas and
Okay, Bharat Petroleum is there, Indian Petroleum is there, HP Petroleum, Hindustan Petroleum is there, and Reliance Petrol also there. So these are the different petrols are there. The ultimate objective of petrol is we know. So here, which petrol we are using, that is important. And the car, the driven by us is important. The road condition, another factor in addition to the brand of petrol used. Brand, which brand we are using. So all these factors we are going to consider. Okay. So here, different factors we have to consider. Road condition, say petrol mileage. For example, you are using a two-wheeler, you are traveling to a village. In the village, how the road conditions are there? You know. Why? Because uh, the forest area or in far rural remote areas, there the government will never focus. Sometimes, okay. Now the situation is different, but in some villages, in some small villages, where the group of people are living 20 houses or 10 houses in parts they are living. To their place also road is not there properly. At that time, how we are driving a car and the road condition, the what which brand we are using, the petrol brand. Okay, all these factors will be considered. So in that way, two factors also involved. So when it is believed that two independent factors might have an effect on the response variable of interest, it is possible to design that the test so that an analysis of variance can be placed, can be used to test for the effects of two factors simultaneously. Such a test is called a two-factor analysis. With the two-factor analysis of variance, we can test two sets of hypotheses with the same data at the same time. The question looks very normality. ఓకే క్వశ్చన్ లైక్స్ వన్ వే క్లాసిఫికేషన్ క్వశ్చన్ ఎలా ఉందో అదే స్టైల్లో టూ వే క్లాసిఫికేషన్ క్వశ్చన్ ఉంటుంది బట్ వీ నీడ్ టు ఐడెంటిఫై ద క్వశ్చన్ సో స్మాల్ చేంజ్ విల్ బి దేర్ when comparing with the ANOVA one-way classification question and ANOVA two-way classification question. So I will clarify the doubt. Okay. So with the same data, we are going to do two-factor analysis at the same time. In a two-way classification, the data are classified according to two different criteria or factors. The procedure for analysis of variance is somewhat different than the one followed. See, the procedure what we followed for ANOVA one-way classification, a little bit different for ANOVA two-way classification while dealing with problems of one-way classification. In a two-way classification, the analysis of variance tables takes the following form. So this is a table. Please take a photo. Okay. Photo తీసుకోండి లేదా రాసుకున్నా పర్లేదు. So source of variation, sum of squares, degrees of freedom, mean sum of squares, ratio of F. So these are the 5 columns. So these 5 columns are there for ANOVA one-way classification and these 5 columns are there for ANOVA two-way classification also. Okay, so between columns, between rows, residual or error. See, between columns, between samples, within samples, between samples, within samples for ANOVA one-way classification. But here, between samples or between columns, between rows, residual or error. This is a one more additional row. First row is between columns, between rows. Third one is residual or error. Okay, then sum of squares, that is SSC, same. V1 is equal to C minus 1. MSC is equal to SSC divided by C minus 1. ఇక్కడ వరకు same in ANOVA classification. Okay, according to ANOVA classification, till here it's the same. Now it will be changes between rows. SSR. Okay, SSR. V1 is equals to R minus 1. Again V1 here. See, in this ANOVA two-way classification problem, V1 in the first case and V1 again in the second case. Two times we have to write the same, that is V1 and V1. Then MSC is equals to SSC divided by C minus 1. Then MSR is equals to SSR divided by R minus 1. Okay, then variance ratio of F is equals to MSC divided by MSE, then MSR divided by MSE. The residual R error, SSE. Okay, then V2 is equals to C minus 1 into R minus 1. See, C minus 1 above value into R minus 1, the second above value. Then MSC is equals to SSE divided by C minus 1 into R minus 1. Then total. Total is nothing but SST. SST. K is equals to N minus 1. This is the table. So, my sincere request to my dear students is that you have to by heart the specimen. Otherwise, it is not possible to get all the values. You have to practice the problem. And you have to byhead this table and you have to practice the problem. After getting all the values, please insert the values. Then automatically the problem will be solved and you will get complete clarity about this problem. ANOVA one-way specimen and this is the ANOVA specimen 2. Okay, just to learn these two tables. Then here SSE stands for sum of squares between columns. SSR is equals to sum of squares between rows. SSE is equals to sum of squares due to errors. Then SST is equals to total sum of squares. Then the sum of squares for resource residual is obtained by subtracting from the total sum of squares between columns and between rows. So here, see in the given problem, we are going to find out the values for SSC and SSR, but and SST also. Okay, these three columns, these three rows, we are going to find the values for these three rows. But to get these values, that is SSE, a small procedure is there. That is SSE is equals to, you look here, SSE is equals to SST minus SSC plus SSR. So you will get a SSC value and SSR value. Then finally you are going to get SST value also. To get that SSE value, okay, to get SSE value here, SST minus SSC plus SSR. Okay, understood or not?
Yes, sir, understood.
Okay. Then total, the total number of degrees of freedom is equals to K is equals to N minus 1. The number of degrees of freedom between columns, that is C minus 1. And here number of degrees of freedom between rows, that is R minus 1. So where C refers to number of columns, R refers to number of rows. Next one is number of degrees of freedom for residual, that is C minus 1 into R minus 1. Okay. The total sum of squares, comma, sum of square for between columns and sum of squares for between rows are obtained in the same way as before. The residual or error sum of square is equals to total sum of squares minus sum of square between columns plus sum of square between rows. Then here conclusion. So in the previous problem, we have written only one conclusion, but in this problem, we have to write two conclusions. ఇంతకుముందు ప్రాబ్లంలో ఒకటే ఒక కంక్లూజన్ రాశాం. We have written only one comment, but in this problem, two conclusions we have to write. Okay, that is conclusion number 1. See here, conclusion number 1. The F value are calculated as follows. F V1 comma V2 is equals to MSC divided by MSE, where V1 is equals to C minus 1 and V2 is equals to C minus 1 into R minus 1. MSC value V1, that is C minus 1 divided by MSE, that is C minus 1 into R minus 1. Then conclusion 2. The F values are calculated as follows. V1 comma V2 is equals to MSR divided by MSE. Okay. V1 is equals to R minus 1 and V2 is equals to C minus 1 into R minus 1. Okay. So note here, it should be carefully noted that V1 may not be same in both cases. V1 is not same in both cases. In first case, V1 is equals to C minus 1. And in second case, V1 is equals to R minus 1. Okay. 2 times మనకు V1 వస్తుందనా ఒకసారి మీరు ఒకసారి చెక్ చేసుకోండి. So you observe carefully. See V1, 2 times. V1 and V1. Okay, na? V1 and V1 here. In first case, V1 is equal to C minus 1. In the second case, V1 is equal to R minus 1. So here the calculated values of F are compared with the table values. So MSC divided by MSC, MSR divided by MSE. So we have to do the calculated value 2 times. We have to write the conclusion here. So if calculated value of F is greater than the table value at to assigned level of significance, the null hypothesis is rejected, otherwise accepted. It would be clear from the above that in problems involving two-way classification, a residual is the measuring rod for testing significance. It represents the magnitude of variation due to forces called chance. In this way, we have to calculate. And the another important thing is here, sometimes, see in conclusion 1 and conclusion 2, this is most important. If the calculated value, for example, say we'll write here, for example, the calculated value is 1.24 for first conclusion, and for second conclusion also, we got 0. For example, I am writing here, not exact value, 0.77. So first value is compared with the critical value or table value. So we got less than. Again, we got less than in the second case also. So if this type of situation is there, means you have to write only one conclusion like this. From the above, it is observed that the calculated value in both situations are less than the critical values. Hence, the null hypothesis is accepted. There is no significant difference between the samples. If two values are less than in the first case and the second case also less than, okay, at that time only you have to write only one conclusion. Sometimes greater than. In the first conclusion, 5.78. In the second conclusion, 5.28. Okay, the calculated value in both situations are greater than the table values are critical values. Hence, the null hypothesis are rejected. There is a significant difference between the samples. So in this case also, you have to write only one conclusion. Okay. In less than one conclusion and greater than one conclusion. Sometimes what happens, in the first conclusion, less than you are going to get, and the second conclusion, greater than will be there. So what you have to do, you have to write two conclusions. Okay, conclusion 1 and conclusion 2. So this is the important thing. Okay, anybody in a doubt till here?
Yes, sir.
Okay. So you observe carefully. This is a question. Please note down the question. The tomorrow class we will discuss in detail regarding this question, this problem. Please note down problems. That is, a tea company appoints 4 salesmen A, B, C, and D, and observes their sales in 3 seasons: summer, winter, monsoon. The figures in lakhs are given in the following table. Salesmen, seasons. Seasons, summer, winter, monsoon. Salesmen total. Then here seasons total. A, B, C, D, 36, 28, 26, 36, 29, 28, 21, 31, 29, 35, 32, 29. Okay. So in this given problem, already I done the total, but in examination point of view, the problem will be there till here only. Till here only the problem will be given. Okay, these season totals and grand total and these totals will not mention, but you have to do all these totals only. Exam lo summer, winter, monsoon information is third A, B, C, D is third. Totals ఇవ్వడు. Seasons totals, salesman total ఇవ్వడు. Okay, so we have to do this total. So the question 1, do the salesmen significantly differ in performance? Is there significant difference between the seasons? Yes or no? This is the question. So first thing is that we have to identify that whether this problem is ANOVA one-way classification or ANOVA two-way classification. That is my question. Okay. So to identify one way and two way, see, observe carefully. In the previous problem, schools A, B, C, D. See, this side information is not mentioned. Yes or no? That is the reason the problem belongs to one-way classification. If this side information is available like this, summer, winter, monsoon. So we can say that this is the first way and this is the second way. ANOVA two-way classification model. ANOVA two-way classification model. This problem belongs to ANOVA two-way classification method. Any doubt, anybody? Doubt unema? Adagandi.
Yes.
Okay na?
Okay, sir.
Right. సో మీరేం చేస్తారు రేపటి క్లాస్కి అనోవా టూ-వే క్లాసిఫికేషన్ స్పెసిమెన్ బై హ్యాడ్ చేసుకొని రావాలి దాంతోపాటు ఇంతకుముందు ఒక హోంవర్క్ ప్రాబ్లం ఇచ్చినాను ఆ ప్రాబ్లం చేయండి దెన్ నెక్స్ట్ ఇన్ అడిషన్ టు దట్ అనోవా వన్-వే క్లాసిఫికేషన్ స్పెసిమెన్ ఆల్సో యూ హ్యావ్ టు బై హ్యాడ్ okay if you
Okay.
by had these two specimens then it is very easy to do the problem so meanwhile we have 3 more minutes okay I request you to ask the doubts in our ANOVA one-way classification. Everybody, any doubts? You can ask the doubts. You can ask the doubts. Anybody? No doubts, huh?
No, sir.
ఎవరికి ఇలాంటి డౌట్స్ లేవా అర్థమైంది అందరికి
Yes.
ఓకే సో వి హావ్ ఓన్లీ వన్ మోర్ మినిట్ సో హియర్ ఒక్కసారి ఇక్కడ చూడండి అమ్మా ఇలాంటి ప్రాబ్లం టూ-వే క్లాసిఫికేషన్ ఇచ్చినప్పుడు నోట్ నెంబర్ 1 and note number 2 these two notes are important so tomorrow we are going to do the problem in detail but we have 1 more minute so we'll discuss regarding note number 1 and note number 2 so used coding method subtracting 30 from the given numbers okay salesman total and seasons total just forgot it so use coding method subtracting 30 see first column A and summer that is row 36 is there. So from 36 just remove 30 do subtraction 30 you will get answer is 6. Sir, what is this 30 sir means? This 30 says that the coding method for subtracting the values. Why? Because 36, 36, 21, 35, 28, 29, 31, 32. These are the sometimes big values will be there. So in to do the problem in a very easy way, we have to use this number 30. So for each problem, you have to use 30 sir means no, don't use the 30. Sometimes what happens, in the given question only, the examiner will give the code number for subtracting the value is 30. The code number for subtracting the value is 40. The code number for subtracting the value is 60. He will give the value, coding value. Okay. If nothing is mentioned in the question, follow note number 2. The above point is not given, then do 360 divided by 12 is equals to 30. So you observe carefully in some questions, salesman total, seasons total will be there. Total will be not mentioned. Only the variables will be there. Salesman total and seasons total. So the grand total is 360. 360 divided by how many samples are there? In column 1, column 2, column 3, column 4, 3, 3, 3, 3. So total 12 values are there. Okay.
Yes.
So sometimes instead of 360, there will be 450 will be there. 450 divided by 12. Okay. 450 divided by 12. Wait a minute. Okay. So here 360 by 12. So that is 30. So sometimes what happens instead of 360, there the value, the number is different. See, for example, 450 is there. 450 divided by 12. So you got 37.5. So you take 37.5 only. Otherwise, 456 by 12. You will get 38. In the place of 360, the grand total is 456. So to get code number examiner question లో ఇవ్వకపోతే ఈ మెథడ్ ఫాలో కావాలి. Note number 2. Okay. So I think you understood. So tomorrow we'll solve this problem. See by observing this answer. See, ఇక్కడ చూడండి. The above data are classified according to criteria, salesmen and seasons. In order to simplify calculations, we code the data by subtracting 30 from each figure. The data in the coded form are given below. Seasons, salesman, summer, winter, monsoon. 36 minus 30 plus 6 ఇలా చేయాలి. Okay. So it's already time up. So tomorrow we'll meet in the morning time. So actually according to the timetable, so our QT class is morning, but one madam, I think she is busy with other work. That is the reason she asked today morning. So I will take in your time, sir. She requested. ఓకే రేపు పొద్దున మాత్రం మన టైంలో క్లాస్ ఉంటుంది. ఏ టైం ఉందమ్మా మన క్లాసు?
మార్నింగ్
10
10 కి స్టార్ట్ అవుతుంది.
10 టు
10 to
11 10 to 11:30 రేపు తీసుకుంటా. ఓకేనా? సో మేడం వేరే
ఓకే
పర్సనల్ పని ఉంటే ఆ మేడం టైం నా టైంలో మేడం తీసుకున్నది, ఆ మేడం టైంలో నేను తీసుకుంటున్నాను. ఓకేనా?
ఓకే
రైట్. సో
ఓకే
థ్యాంక్ యూ వెరీ మచ్. టుమారో 9:55 నేను వచ్చేస్తాను ఆన్లైన్లోకి. రైట్. థ్యాంక్ యూ వెరీ మచ్.
ఓకే
సో మీన్ వైల్ జస్ట్ by hand and practice the problem, home problem, and the problem which we done in the class today, that problem also you have to practice. So if you do practice, then only you will get the doubt. Otherwise, you won't get that doubt. Now itself, you do
ఎస్
practice. Okay? Right. Thank you very much, all of you.
Thank you, sir.
థ్యాంక్
Thank you, sir.